Hi, I'm Peter Hill and I'm teaching new science for the StarsTV Science education channel. Last program we learnt how to approach an experiment so that you can get maximum marks, think like a scientist, and bundle it up so it's easy to understand and communicate. One of the very first experiments you get to do when you first come to high school is boiling water. It seems very simple, and there's lots of simple explanations, but there is an awful lot of complicated science behind it. And we're going to start by unpicking it piece by piece. We're going to devote our first program to the very first step in this experiment of boiling water. You get your beaker, you fill it with water, you leave it for a while, and then you put your thermometer in it. And the question we have is, what temperature do you expect it to be? It's been there for a while. Will it be room temperature or will it be something else? The surprising answer is that your beaker is a little bit less than room temperature. This is because the surface of the water is evaporating. It wouldn't do so if you put a lid on the beaker, but it's exposed to the air, and higher energy water particles can leave the surface, lowering the average energy of particles inside the water. This is where science explanations can be a little bit tricky. You have to know several concepts like temperature, water particles, room temperature, and stick them all together, and you have to start attempting to understand at various points, and little by little it will all come together. So stick with me for a while. Now I want you to imagine a water particle or a water molecule sitting on the very surface of the water. Now it's getting hit all the time by other water molecules underneath it, but on this occasion it gets hit by two water molecules at once. When it does this, it has enough energy to leave the surface, and I have this image here for you to look at. Perhaps you can guess what it is. It is, in fact, a billiards table. A trick shot on a billiards table, but I've reversed the sense of time in the film so it's running backwards. It's filmed in slow motion and with a special camera where the different temperatures are different colours. That's an infrared camera. Now you can see from here that running forward, the ball hits two balls and they move off. Now if you run it backwards, the two balls hit the single ball and appears to shoot forward. Now that's not standard in a billiards table, but it is standard in water molecules where lots of water molecules are continually jostling all the time, and you can see that that little water molecule gets shot off the surface, and that's evaporation. Now we've used the science trick of using models. Now, models are things that you do understand, which help you further your understanding of other areas you don't. So we can see from this that the process of evaporation ejects a high energy particle, but it leaves two or more lower energy particles behind. Therefore, over time, the body, which is evaporating, actually cools. Thank you for watching.